Okay, so chapter 4 is the beginning of a new unit in calculus. This is the time in calculus AB where we switch everything we've been doing this year. So far, the first 3 chapters have all been focused on, understanding what a derivative is, applying derivatives, using tangent lines. This chapter, we get to reverse your thinking. We get to study antiderivatives. So it already sounds like fun, doesn't it? So here's the concept. Now we're going to start with f prime and have to work our way backwards and have a reason for doing that. So for this lesson, for this video, let's just figure out how would we reverse something like maybe the power rule, for instance. So here's our question down below here. It says, suppose f prime of x equals 3x squared. Then f of x is equal to what we call the antiderivative. So I have a question for you. If f prime is 3x squared and f of x is the antiderivative, what could f of x equal? Seriously, pause the video and try this. Could you brainstorm and figure it out in your head? What would f of x equal? So if you've sat and thought for a little bit here, you might have figured this out, or I hope you have. It's reverse power rule. F of x would probably be x cubed. Because if you power rule x cubed and you get the derivative, f prime of x would be 3x squared. Alright, so if you figured that out, nice job. Here's kind of the issue though. What if I was a little bit different than you and I had said I think x cubed plus 10 was the original f of x? Would I necessarily be wrong? Well, what's the derivative of 10? It's 0. So that would have worked. I could have said plus 10. But I could have also, let's erase this, I could have also said, no, I think it's x cubed minus 7. And you'd look at it and say, well, what's the derivative of minus 7? Well, it's 0. So I'd still be right. So there's a little bit of an issue when we're anti-deriving. We could have an extra number when we go back a step, like plus 23. Well, the derivative of 23 is 0. And this extra number could be anything. When you think about it, any constant number derives to 0. So when I'm going backwards from f prime of x, I kind of have an issue because I don't know, well, what if there's an extra constant? I need more information to actually figure out what that constant is. So something we're going to learn today, anytime we're anti-deriving, we have to remember there could be an extra number in our antiderivative, an extra constant. But before we totally get into that, let's just talk notation here for a minute. So with antiderivatives, often the way we're going to write it is, let's say our function is f of x, and we want to antiderive it. We want to go back a step. Well, the symbol we use for that's called an integral symbol. It looks like this, kind of a long curve, and we want the integral of f of x dx. And I'll kind of go through these notations. So this thing is called the integral symbol. And it's the symbol telling you to antiderive something. So it's kind of like your directions. When you see that symbol, you're like, oh, it's asking me to antiderive the function f of x. Well, f of x is known also as the integrand in this problem. It's the thing we want to antiderive. So it's the integrand. It's the function, but it's also the integrand. dx, we're going to get into what this means. Now the dx is a little more complicated and there's more meaning behind it. You'll have to watch more videos later on to understand it. But for now, what you got to remember is every integral has a dx or a d something, and it's the variable of integration. The variable of integration. And so these are kind of the 3 parts that you need to understand as far as notation today in this video. We've got an integral, an integrand, and a variable of integration. And I'm going to show you some examples. We're just going to practice reversing the power rule today and using this notation. So a little definition for your notes is integration is the process of finding an antiderivative. So we have differentiation is the process of deriving. Integration is the process of anti-deriving, and you'll see that in class when we're doing our worksheets and practice problems. You'll see integration as the directions a lot. Alright, so example, integrate f of x equals 12x to the 5th. Reverse power rule, 12x to the 5th. So here's how we're going to write this. We're going to say we want to find the integral of f of x with respect to the variable x. X is our variable, dx. We want to know, what does this equal? So you could sit here and kind of brainstorm, what would power rule to 12x to the 5th? In fact, you could pause the video and try and figure it out just to kind of see how fast you are. But I think that when I see 12x to the 5th, I would like to be able to do it without having to sit here and guess and check in my head. So here's the strategy. I'm going to rewrite 12x to the 5th. Remember how power rule works? You subtract one from the variable, or subtract one from the power. Reverse that concept. Reverse it and add 1 to the power. So it's going to be 5 plus 1 to go back to the 6th power. But you got to do a little bit more than that. You have to take that 6 that you get up here and divide it over here. Meaning we're going to have 12 divided by 6 is 2x to the 6th power. Because think about it. If you derive 2x to the 6th power, 2 times 6 is 12, and it'd be 12x to the 5th. So our antiderivative is 2x to the 6th, but there is a little bit of a catch. Because we have a constant that could be added onto this, a plus something, we're going to write plus c. And this plus c, I think it's really important that you write a note down about this. Every integral has a plus c. Every time you're anti-deriving an equation, you get this plus c. And it represents any number, any constant that could possibly be a part of this function. Any constant. Now think about this for a moment here. Checking your answer, if you were like, gosh, I wonder if I got my answer right, all you have to do is derive this to check and see if you got it right. So think about it. 2x to the 6th would be 12x to the 5th plus the derivative of c. Well, c is just a number. The derivative of c would be 0. I get 12x to the 5th plus 0, which is exactly what my function was. So you can do that. You can do that in your head. You can do that on paper just to kind of check yourself. But you want to make sure that you're doing it right. So here's your answer. 2x to the 6th plus c. And it equals the antiderivative of f of x dx. So those are my labels. So maybe pause this next one and try it yourself here. What is the antiderivative of h of x? Equals 5x squared plus 4. H of x equals 5x squared plus 4. So here's how you write it. You write the integral symbol of h of x dx. We want to antiderive h with respect to x. We're going to take the 5x squared and just write it down. And we're going to reverse the power rule. So we're going to be adding 1 to it, which makes 2 plus 1 is 3, and dividing by that 3. Now, plus 4, we're going to antiderive. So thinking backwards, what would derive down to just give you the answer of 4? So I'm thinking 4x. Remember, the derivative of 4x is just 4. So we're going to put a little 4x there. But then we also have to remember to add our plus c, our constant. So technically this is the answer, but I'm going to clean it up to 5/3 x cubed plus 4x plus c. And it equals the antiderivative of h of x dx. And that is my answer. Now you can go off in your head here for a moment and have a little bit of a thought and double check that you're right. You could be like, you know what if I power ruled the 5/3 x cubed? It'd be 3 times 5/3 x squared. And the 3's would cancel to 5x squared. Well, that's exactly what we had up here. So you can check yourself and be like, am I doing this right? Do a little power rule off in your head. You don't have to show this on paper. You can just do this kind of up in your head and kind of think about it, but it'll help you get the right answers. So what about this one? Integrate w of x equals negative x squared over 2 plus 3x plus 1. So we're going to antiderive w of x with respect to x. We're going to take this whole problem, negative x squared over 2, I'm going to rewrite that as negative 1/2 x squared. And the idea is we add 1 to it and divide by it. So we're going to add 1, make it to the 3rd, and divide by 3. We're going to take plus 3x, which is technically to the first power, and we're going to add 1 to it, so it makes it squared, so we'll have to divide by 2. We're going to take the plus 1, and we're going to realize to antiderive plus 1, you just add the variable back to it. And then we're going to remember our plus c for our constant. And so this whole messy thing is our answer, but clean it up. Negative a half divided by 3 is negative 1 over 6. X to the third power plus 3 halves times x squared plus an x plus a constant c. And our integral is antiderivative of wx dx equals negative 1/6 x cubed plus 3 halves x squared plus x plus c. And there's my answer. So the focus on this video was you kind of understanding the concept of reverse power rule. So instead of subtracting 1 from the power, you're adding 1 and then dividing by it on the bottom. Reverse power rule. Okay, I hope that helped.